4-7 inverse trig functions. You've done inverse trig functions in the past. When we did them in the past, we did them with equations, if you remember right. Okay? And what we did was, we swapped out the x and the y values. We swapped out the x and the y's in the equations, and then we solved for the y value, and we got our inverse functions. Well, trig functions work the same way, sort of. But for us, for a function to be an inverse, first of all, it has to pass the horizontal line test. Okay? So we're going to talk about sine function first. Now, a normal sine function, if you remember right, the way it looks, okay, it looks like this. It goes up, down, and back up, or in the reverse. And that's our pattern for a sine function. Now, let's think about this. To pass the vertical line test, we're good. Up and down, we're good to go. But it does not pass the horizontal line test because it hits in more than one spot. Since it doesn't pass the horizontal line test, we have to restrict it so that it does. So taking a look at our graph, we only want the section of the graph where it will pass the horizontal line test. And you usually start at the origin. So this section we're good, and this section we're good. So basically from here, which is negative pi over 2, to here, which is positive pi over 2, we will pass the horizontal line test. Anywhere after that, as soon as we get past pi over 2, we don't pass it. As we go behind and back of negative pi over 2, we don't pass it. So as long as we are restricted to between negative pi over 2 and positive pi over 2, our inverse function exists. Which means we are restricted to landing between, according to our chart, if this is 0, this is pi over 2, where would negative pi over 2 land us? Down here. So we are restricted to landing between quadrant 1 and quadrant 4. 1 and 4. We are not allowed, sine inverse therefore doesn't exist when you land in 2 and 3. Okay? So to write a sine inverse, you've done it in the past, sine inverse, we usually use a -1. You could also use the words arcsine. You need to realize that means one and the same. Now when graphing then, when graphing inverses, just like before, we said the x and the y values swap out. So what happens is the x-axis and the y-axis reverse themselves. So sine of x can be in any quadrant, but sine inverse can only be in quadrants 1 and 4. So if I do that off here to the side, what I'm talking about here, if I graph that, the x and the y-axis swap out. So now this axis becomes pi and 2 pi. And this would be our 1 and our -2, and so on. Now, remember how we graph them? Normally we hit at 0, 0. At a half a pi, we're out to 1. Well, then we're back to 0. -1, 0. Or reverse it. We'd be here. So our graph looks like this. Sorry. So this is the graph. Kind of deal. So again, the only parts we're allowed to use is this. That's it. So we're going to use this information to answer some questions now. Okay? You're going to need your chart. Okay? So get your charts out. That would be these things right here. You're going to have to use your chart, which is located right here, and the bottom chart to get some of your answers. Okay? This is how they work. Suppose I asked you just to look up the sine of pi over 4. Using your chart, you would go to sine, go over to pi over 4, and your answer would be square root 2 over 2. Well, to do an inverse, you use your chart in reverse. Normally, we take a look at the angle, and we go down, and we get our x and y value. Well, to do it in reverse means they're going to give us the x and y value, and we go back to find our angle. So, to do arcsine equals -1, When does sine equal -1? Well, use your chart. Find -1. It's not here, but it is down here. Sine is -1 at 3 pi over 2. So we get 3 pi over 2. Well, that's a problem, because sine has to be restricted between -half a pi and +half a pi. That means it either has to go up or it has to go down. 3 pi over 2, though, however, goes like this, all the way around to here. And we're not allowed to go into quadrants 2 and 3. And if you're not allowed to go into quadrants 2 and 3, you have to figure out another way to get there. So we have to get to the spot, and we're only allowed to go up through quadrant 1 or down through quadrant 4. So going downward means negative. And since this is the same value as negative pi over 2. Sine inverse of 1/2. So you go to your chart. You go over to sine equals 1/2. Go up and it says pi over 6. You're done. Now what if I asked you to find the sine inverse of a -1/2? Well, this is what makes sine really easy to do. If it's positive, it's normal. If it's negative, negative just means go downward and make it a negative. So you would still look up the positive version, sine of 1/2, which is pi over 6. But because it's negative, just make it negative. Like up here, we could have looked up when sine was 1. And sine is 1 at pi over 2. And because it's negative, we just make it negative. The next one, sine inverse is the square root of 3. Unfortunately, if you look for sine here and here, square root of 3 does not exist. So you have to do the decimal version of it. And if you type in square root of 3 on your calculator, you get 1.73. Now, where is that going to land us on our charts? Well, let's think. Pi over 2, which is 1.57. Negative pi over 2 would be negative 1.57. Where will 1.73 land us? Well, it's going to be bigger than 1.5, but less than 3.414. So that's going to put us in quadrant number 2. Your graph does not exist in quadrant number 2, so this one is a no solution. Cosine inverses. Okay? Let's think about what a cosine graph means. It looks like this. Starts at 1, goes down, up, and back again. So the first thing you have to ask yourself is, where does it repeat and where does it not repeat? Well, it starts here at 0. Let me know when you get to the point where you see a repeat. As you're going down, 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 oh, right there. At -1. Keep in mind, this is half a pi, this is pi, this is 1.5 pi, and here's 2 pi, isn't it? So as long as your graph falls between 0 and pi, you're good. So that's why cosine inverse is restricted to landing between 0 and a whole pi, which puts it, according to our rules, in quadrant 1 and quadrant 2 is the only place it's allowed to land. It's not allowed to go into 2 and 3. Cosine inverse only exists in those quadrants. Now, if cosine inverse is positive, you leave it in quadrant 1 and it is normal. You get a normal theta. Whatever it is when you look it up, that's what it is. But when you land in quadrant number 2, quadrant number 2 inverse happens when your cosine is negative. And here, you got to take your reference angle, which means you're going to look it up in your little chart, your positive version of it, but then that's going to give you an angle out here somewhere. This is your theta prime. That's going to give you your reference angle. But what you're really looking for is this part. And to get that answer, your formula would be pi minus your theta prime to get to a negative. So let's do some examples. arc cosine of square root 3 over 2. So you're going to go to your chart. You're going to go over cosine, find square root 3 over 2, and go straight up and get pi over 6. Done. Positive is normal. What it is, what it is. Cosine inverse, negative 1/2. So you're going to look up the positive 1/2 version. So when does cosine equal positive 1/2, and you get pi over 3. But because it's negative, you've got to send it to quadrant number 2. And when you send something to quadrant number 2, that's over here. So this angle represents pi over 3, this little one. Well, you need how you got there. And how you get there is by taking pi minus your theta, pi over 3. And a whole pi minus a third of a pi, final answer, 2 pi over 3. And you're done. Tangent inverse. Let's think about what a tangent graph looks like. Pi over 2, negative pi over 2, goes up and down. Well, definitely passes the vertical. What about the horizontal? That entire graph passes the horizontal. When does it not pass the horizontal? Is when you get past pi over 2, because when you get past pi over 2, that's when you got your repeats. Then you would no longer pass it, would you? But as long as you stick to being between negative pi over 2 and a positive pi over 2, your inverse exists. So, that means as long as you stick between 0, pi over 2, and negative pi over 2, your inverse exists. So how does that affect your graph? Well, if you land in quadrant 1, then your tangent inverse, which is positive, is normal. Your answer is going to be normal theta. If you land in quadrant number 4, your tangent inverse has to be negative, negative because it's going downward, then your theta will just be negative. Just give it a negative answer, just like sine. So we can use that to look up our answers. Arc tangent of 1. When does tangent equal 1? So we go to tangent, we go over to where it says 1, and it says pi over 4. Pi over 4, we're done. Tangent inverse of a negative square root 3 over 3. So you go to tangent, square root 3 over 3, you look at the positive version, which is pi over 6. But because it's negative, negative means you have to go downward that much. And to go downward to negative pi over 6 just means you make it negative. So keeping this in mind, we can set up some rules for us. We could know that if you have the sine inverse, okay, and the tangent inverse, if they are positives, then you're in quadrant number 1 and it's a normal theta. You leave it alone. But if you're looking up the negative version, you got to send it to quadrant number 4 and you want a negative theta answer. Cosine inverse. If it's positive, that means you're in quadrant 1 and you get a normal theta. But if you're negative, you got to send it to quadrant number 2. And to get your theta for quadrant number 2, you got to take pi minus your theta to get it. So it depends on where you land and what you get. Now these are properties of double sines and sine inverses. So here's how it works. You have a sine on the outside. Sine is normal, what we're used to seeing. A sine graph, if you remember right, looks like this. Goes up, down, and up. And because you're taking the sine of some amount, that amount, according to this graph, cannot get higher than 1 and negative 1. So as long as your graph lands between a negative 1 and 1, then sine and sine inverse cancel each other out, and your answer is just your x. Now think about sine inverse, however. This one has sine inverse on the outside. Sine inverse had its own restrictions, remember? You're only allowed to land in quadrants 1 and 4, which means you are restricted to landing between a negative half a pi and a positive half a pi. So, if your value inside is in between those, then the sine inverse of the sine cancel each other out, and your answer is just y. If they don't cancel, if your number falls outside of 1 or outside of this, then you're going to have to look them up manually in your chart and figure out what to do with them. Let's talk about cosine. Cosine graph, same deal. Starts at 1, goes down and comes back up, but its peak are 1 and negative 1. So a cosine graph cannot go outside of a 1 and a negative 1. So as long as you got a normal cosine on the outside and it lands between normal cosine on the outside and it lands between negative 1 and 1, then the cosine and the cosine inverse cancel each other out, and your answer is just the x. Now, cosine inverse lands between 0 and pi. So as long as your y value is between 0 and pi, then they cancel each other, and your answer is just y. Now, tangent version. Tangent looks like this, doesn't it? It goes up forever, down forever. So, what's the height that you reach? Well, it goes on for infinity and negative infinity. So, everything works when you got a tangent on the outside. So, when you have a tangent on the outside, tangent and tangent inverse cancel each other out, and your answer is just x. But tangent inverse, however, does have a restriction. It was restricted between a negative pi over 2 and a positive pi over 2. So, if your value lands between those, then they would cancel, and your answer would just be y. If you have something else, you have to look them up in your chart. So let's do some examples. Arc sine of the sine of 3 pi over 2. Because you got arc sine on the outside, that means you are restricted to being between a negative pi over 2 and a positive pi over 2. Unfortunately, 3 pi over 2 does not land inside there, does it? So we are going to have to look up the sine of 3 pi over 2 and substitute it in. So if you use your chart and you look up the sine of 3 pi over 2, you get negative 1. So we can replace this right here with the negative 1 and write it as the sine inverse of negative 1. Now that I know how to look up. I look up the positive version, and because it's negative, I just give it a negative sign. So on my chart, I'm going to look up sine of 1, which is pi over 2, and because it's negative, I just make it negative, and I'm all done. The next one, I got a tangent on the outside. Tangent has no restrictions, and since it has no restrictions, the tangent and the tangent inverse cancel each other out, and your answer is just negative 5. Arc sine. Arc sine has a restriction. Negative pi over 2. Okay. Negative pi over 2 and a positive pi over 2. Unfortunately, 5 pi over 3 does not fit that qualification, does it? So we are going to have to look it up. And you're going to have to do it the way you've always done it in the past, the normal way. So, 5 pi over 3, we got to figure out where it lands, don't we? Because if you land in quadrant 1, you're normal. If you land in quadrant 2, it's pi minus. If you land in quadrant 3, it was theta minus pi. And if you land in quadrant 4, it's 2 pi minus theta. Those were our rules. So where will 5/3 land us? Well, that's really 1 2/3 of a pi, isn't it? So let's figure out where we land. Let's go around our circle. There's 1 pi, and we need 2/3 more. So that puts us down here in quadrant number 4, doesn't it? Which means we have to take 2 pi minus 1 2/3 of a pi. So that's going to give us pi over 3 is what we're going to look up. So we're going to go to our chart. we're going to go sine pi over 3, square root 3 over 2. And because it's in quadrant 4, it's negative. It's going to be negative square root 3 over 2. That's what the sine of 5 pi over 3 is. So now we can replace it up here in that. And we could say arc sine of that. Remember how sine works? You look up the positive version, and if it's positive, you leave it alone. If it's negative, you make it negative. So go to sine square root 3 over 2, and you get pi over 3. And because it's negative, you just make it negative pi over 3. Done. Cosine. Cosine is restricted to being between -1 and 1. Pi is 3.14. It does not fall inside that range, does it? So you would have to look up the cosine inverse of pi. Well, cosine inverse of pi has to fall between 0 and pi. Fall between 0 and pi, which means you can't look up pi. And if you can't look it up, your answer is no solution. And you're done. Now, other ways we can do this. Those rules we just had only applied because you had sine, sine, cosine, cosine, tangent, tangent. What if you have them crossed over with a tangent with a cosine or a sine with a tangent? Okay? To do those, you have to use what is known as right triangles to find your inverses. Okay? So the first thing you have to do is you have to figure out what quadrant you're landing in. Now, since this is a cosine inverse, right? Cosine inverse is restricted to quadrants 1 and 4. Well, since this is positive, we know we're in quadrant number 1. So we can go ahead and draw ourselves a triangle in quadrant number 1. Remember doing this? Put our little theta in. Now, we also know that since it's cosine, the formula for cosine is adjacent over hypotenuse. So, the adjacent side here will be 2. The hypotenuse side will be 3. So we need to figure out this one, don't we? Using our Pythagorean identities. So let's do that. So we've got x squared plus a 2 squared has to equal a 3 squared. We solve that, we have x squared plus a 4 equals 9. And we subtract, x squared equals 5. So x is equal to the square root of 5. Then you have to decide if it's positive or negative. Well, look at x. It's going up. So it's definitely a positive square root 5. Now, once we have a little triangle, it's actually pretty easy. We've already taken care of, we used this part right here in the center to come up with our triangle. So now we just got to find the tangent of theta. Tangent, if you remember right, means what? Opposite over adjacent. So the opposite on this one is square root 5. The adjacent is 2, and I am done. So my answer to the whole thing is square root 5 over 2. Finished. Sometimes, and a lot of kids do this, they prefer triangles. Triangles actually make it kind of easy to do. But unfortunately, in order to use a right triangle, you have to have an inverse on the inside. If the inverse is on the outside, you can't use a right triangle. Right triangles only work when your inverse is located inside. So take a look at the last two. I've got an inverse on the inside, so I'm allowed to do it. But this sine inverse is negative. Sine inverse is negative in quadrant number 4, right? So that means when we draw our triangle, we got to put it down in quadrant number 4. So there it is in quadrant number 4. Put our little theta in. Now, sine, if you remember right, is opposite over hypotenuse. So the opposite side is going to be 3, our hypotenuse is going to be 5, and since we're going downward, we're negative, aren't we? So we got to find our missing side. So we can use Pythagorean again. X squared plus negative 3 squared equals our 5 squared. So x squared plus 9 equals 25. Subtract them. X squared equals 16. So x is going to be 4. So once you put it in, you can then decide, since it's going towards the positive, it's a positive 4. So now use it to find cosine. Cosine is adjacent over hypotenuse. So the adjacent side is 4. The hypotenuse side is 5. So my final answer for the whole thing, 4/5. Last one. Tangent inverse. So we're allowed to use our right triangle. Tangent is negative. Tangent is negative, again, when you land in quadrant number 4. So you're going to make your triangle in quadrant number 4. Tangent, though, is opposite over adjacent. So the opposite side is going to be 3. Your adjacent side is going to be 4. And since 4 is going towards the positive, 3 is going downward, it's got to be the negative one. Because right out front here, you don't know. So this time we're trying to find our hypotenuse, aren't we? So we can just do 4 squared plus a negative 3 squared equals our x squared. So that's 16 plus 9 equals x squared. So 25 equals x squared. So x is just nice, neat 5. Now that we have our triangle, we can get our cosine. Cosine is adjacent over hypotenuse. So adjacent is 4, hypotenuse is 5, final answer, 4/5. So the whole thing comes out to be 4/5. And we're all done.